So as we see here, that is a transmission system connected to the wheels, and we have an electric motor which can be AC or DC depending on the company which is making the vehicle, and we have a drive system, the motor drive system connected to battery stacks and which are provided to DC links, and we have various bidirectional converters, and if some cases supercapacitors are provided. So this is one such architecture I have provided, and this paper has been published in Journal of Energy Storage 2022. Now electric vehicles require various kinds of semiconductor devices for their operation. So this paper lists down the various technological advancement related to the semiconductor chips to be used for the converters used in electric vehicles. Okay, so mostly we are using this silicon carbide based MOSFETs. Okay, gallium nitride based devices are also used. Now, what are the various technological aspects when you consider design of electric vehicles for energy efficiency? What are the various technological aspects? The devices classification, their performance issues, figure of merit, what are the various commercial devices available, what are the type of technologies, what kind of motor are used, what kind of chargers, converters, switching frequency, efficiency, thermal management, reliability, power density, power rating, number of power components. What are the energy management systems which are used for energy storage and charging. So a comparison of energy retention time against the power range of the electric vehicles. So we see here a graph between power versus storage time. So as you see here, so more power can be stored in pump hydro, which of course cannot be used in electric vehicles. So these are for large scale power, and chemical, thermomechanical storage, 5-well supercapacitor. So these somehow can be integrated into the electric vehicles batteries so as to improve the storage time. Now a comparison between power density and the energy density. So capacitors have very high power density but not much energy density. They cannot store too much energy. Okay, whereas batteries are very good high energy density, but they cannot provide as much power as the capacitors. Then we have got symmetrical supercapacitors, and the best one as per research is the hybrid supercapacitor, organic symmetrical supercapacitors, aqueous symmetrical supercapacitor, etc. So that's where the research is concentrated. So what are the operational features for battery management system? There is a database, the BMS engine, there is the application, some drivers, some systems, real-time systems, hardware, real-time operating systems, and microcontrollers. So these are already integrated. If you drive any electric vehicles, you can always feel the presence of the battery management system, which suppose you go on a cruise control mode, then in that case for petrol and diesel vehicles the fuel input is controlled, but when you go on a cruise control mode, to maintain the constant speed, the whole responsibility lies with the battery management system. So what are the operational features for such a battery management system? As I said, events like cruise control or all these things, whether regenerative braking. So in regenerative braking, the battery should not discharge, it should be charged. Okay, but what if the battery is 100% charged? So and you simply leave the accelerator. So whether it will charge the vehicle, it cannot, because it is already 100% charged. then state of charge, electrochemical charge, then state of charge, ampere hour counter, etc., simulation module, sensor data, SOC validation decision. So this is where many BMS fail. As I have seen in many battery electric vehicles, the BMS is not perfectly judging the SOC while making, say, regenerative charging or whatever. Sometimes the charge shows 100% even if the charge has reduced to 95%. So this is one area of improvement that is expected to make made in future vehicles. So this is one model for heat flow, and the heat flow is very important.
Sir, you
Yes,
have one.
yes, yes.
Can you tell about the one I just asking only
Yeah.
in BMS? What type of research we can do by battery systems? How battery behave? Suppose we want 7.5 ampere hour, 12 volt, any other. What type of research? What are the possibility in research in this area?
See, practically what problems I have seen BMS does, for example, you take any commercial vehicle and you have put the cruise mode. So in the cruise mode, the purpose of the BMS is to fix the speed. Suppose you have put the cruise mode at 80 kmph. Okay. Now once you run the cruise mode, the battery is running at 80 kmph, right? Fine. Now suppose you remove the cruise mode because the traffic comes. Okay. The BMS behaves abruptly. Okay. So BMS is unable to distinguish between the cruise mode and the normal mode of operation. So one category of research, I think it is possible that you decide whether how the BMS will accurately determine how BMS accurately determines the driving modes.
Yes.
This
Okay, sir.
can be
Continue.
one.
Data
Yes.
we are talking.
Okay. So next is heat flow. Okay. So this is, as you see, so we'll see another such diagram. So it's a smaller one. Okay. So if you see, we have a condenser, evaporator, cables, compressors, and we have got this battery liquid cooling loop. So this is the thermal management system for the electric vehicles. This is the battery liquid cooling loop. Okay. Then EV power demand to the load, and this is the vehicle. Okay. And we have got a battery pack, chiller, and all these things are there. These are all available inside the vehicle. So this is a typical one such model. There are several models available for cooling system. This is one such model, and these are the structure of the cooling plates. So as you see, all the battery, you might have heard about batteries being burst or fire incidents in earlier cases, in many earlier cases, but now things are matured. But every battery is provided with such cooling plates, and there are several such modules which are separate modules, and we have different way how heat is transferred between the modules, so coolant flow in the cooling plate. So this coolant must follow a particular path, so that the heat that is generated inside the batteries during running of the vehicles, okay, so they follow a particular path that must be properly designed. So this is what, as you asked, BMS, how the battery management system can also coordinate with the cooling system. So the coordination between BMS and the cooling system, that there is one such area.
But here, sir, what is the
Yes,
research point where we can do research work? Suppose BMS we have it. So what is the research component? It means in that place people can work these things.
I would suggest first to make the model of the BMS. First is
BMS,
modeling the BMS, right? Isn't it? First we have to make a model, right? Modeling the BMS, right? Then you model the cooling system, which is actually a thermal model, right? Modeling the cooling system, and then integrate both, right? Isn't it appearing to be a right direction? Because many the problem is happening with the cooling system.
Ah,
The BMS is
oh,
unable
continue.
to coordinate, I think. Okay. So you can refer to this paper. So I will again guide you to this paper. See this one. Yes, this paper is a very nice one. It has given all the range of issues, including issues in the BMS. I have not provided here, but they have also provided various architecture of the converters and also BMS control systems. Okay. And recently what I have seen is they are trying to use this AI based technique like reinforcement learning to include in the BMS, but that will be only relevant for research perspective. But if you want a practical approach, I think this BMS, cooling system, all this integration you have to make first as a model, mathematical model, then you can, I think, create the hardware for that. There are many research which have also given the photos of the hardware that they have used. You may simply search battery efficiency in any research portal and you can find out the papers. Okay. So future research directions that will see. So we have discussed so far only electric vehicles. We have researched only electric vehicles. Now other vehicles are also there like hybrid electric vehicles which have fossil fuel input also. Then we have got fuel cell based electric vehicles. Several such things I have seen in the research. So we'll just have a discussion on all this. Okay. Now starting in this part, the first and the most important part is the charging. Is the charging part. Now, as I have said, we can have home-based charging system with a very low charging cost, like rupees around 5 per kilowatt hour on an average. Whereas the charging stations that are commercial, they charge about, currently in Orissa, it is about rupees 19 per kilowatt hour, which is very high, 4 times. Okay, and this is a typical charging system. So we have got these EVs, and we have a charging station. Okay, and this system I have never seen practically implemented in our country, but it's a theoretical one that we can have PV systems also. But then PV can provide only energy. PV can provide only energy because during the night PV won't be available and the peak value of PV will be around say 11 AM to 3 PM. So it can provide only energy for maybe charging the battery or whatever, or exporting to the grid, that it can provide. But actually we need to have this grid which should be available. In fact, many of the northern states, the problem is with the grid availability. Okay, you are charging and midway the power goes off and it doesn't come for next 1 to 2 hours. So that is a problem. Okay, and if we consider a charging station and where the cost is 4 times higher than what we are seeing at home, then such type of charging stations do not have any meaning. Okay, people are not going to go to charging stations just because they want to charge. They simply can charge at home. Okay, and this I have got from the internet, and various textbooks have also provided what are the various methods that we have for battery charging. So one is constant current, means a steady current, often used for NiMH batteries, but nickel metal hydride. Charging at roughly 10% of the maximum battery rating. So at home, when we use that 3.3 kilowatt charger, it is mostly constant current charging. Okay, constant voltage charging applies a fixed voltage, allowing current to taper down. So most of the commercial chargers that we see here are constant voltage chargers. Constant current, constant voltage charger, hybrid methods. Okay. Now nowadays you will find many new charging stations, they come with the power electronic devices based pulse charging. So intermittent charging, and it is one thing we must be very careful about. See, charging method significantly affects the battery life, right? Suppose you have done a slow charging at home with a 3 kilowatt charger and your car shows 200 kilometer range, and when the charge is about 50%, you go to a fast charging station, do the charging, and you will find that for the rest 50%, your range might be say 20 to 30 kilometers more. So it depends on the behavior of the battery. So this is one research area we can say how charging method can affect the range of the battery or the range of the electric vehicle. So whether we should go for, how many times should we go for fast charging? People will say go for slow charging, fast charging may affect the battery, but it is not that way. You might have slow charging for a longer duration, then suddenly you provide your battery with a fast charging, full charge. In that case, you will see that your battery capacity has improved. Okay, that is happening. So this one we can find out. Then trickle charging is not used here in for batteries. Okay, so that is mostly for power plants. Okay, a new kind of vehicle is fuel cell based vehicles, where you have electric vehicles. Okay, and in addition you have a fuel cell stack. Okay, so this is under research. Then we have fuel cell and battery both. You see here battery pack and the fuel cell pack. Okay, and here we have another architecture where we have one ultra capacitor. So all this can be modeled theoretically, but the challenge is creating such kind of environment or hardware and then testing it. That is mostly happening, I see, in the international research. But in our country, we are mostly implementing these in some simulated environments, not having this hardware everywhere. But it will be interesting to know how these things are performing in a practical setup. And this is a new one that I found out, that source of vehicle is, many BTech students or undergraduate students do such kind of projects, and also commercially small capacity vehicles are also available of this form, where the solar power directly, you have a solar panel which directly charges the battery. Okay, so I will see here. So from PV, so this curve, this orange line, so that charges the vehicle from the PV. Okay, so whether how much this will be practical, that needs to be found out. You can refer to this paper. And another one, which another direction which they have, I have seen in the research, is directly using some wind turbine. Again, so this is, they have provided some kind of architecture, but I am not sure how much wind is actually providing for charging. You can go through it. Okay, and now we come to the last part, like what are the social and financial drivers. Social and financial drivers for adoption of electric vehicles. Now, before going through all this, this is a research from Accelerate. Okay, so they have taken some kind of survey regarding adoption of electric vehicles. So you see here, so risk aversion. One such is risk aversion. I don't want to risk purchasing an electric car since I know a very little about it. And this is the biggest issue. So as electrical engineers, we may have knowledge of what are number of units, how much units will be consumed, or, and in fact you will see many a times the charging stations are not like the conventional petrol pumps. So nobody will be available there. So there will be some instruction that you have to download some app. Then in the app you have to recharge money. So after you recharge the money, automatically in the app you will start your charging. So there is no connection between directly switching on or switching off something. So people who are unaware of, not aware of all these communication, as well as how the battery charge takes place, they might get afraid. They might be afraid. They may not. I have seen people who have, say, 10% charge left in their vehicle and they are in a charging station and they don't know what exactly they have to do to charge the vehicles. Nobody is available to help. Okay, there is a very limited service support for electric cars in India. This discourages me from purchasing an electric car. Service support means, this is a perception. So far I have not seen electric vehicles breaking down, the modern ones at least. I feel that it is not good idea to purchase an electric car now in India, since there is limited public infrastructure for charging. Yes, this is actually an issue, because you cannot take electric cars for longer distances. You can use it for daily commuting to work and all those, because you can charge at home. But longer places you cannot rely on public charging infrastructure. That trust issue is there. Used electric cars have very low realistic resale value. Now some people who are interested in resale value, they won't purchase electric cars because as per current perception it has no resale value. and hence I feel that it's not a good idea to purchase the electric car. I feel that a conventional car is a proven technology, where electric car is not. It discourages me from purchasing electric car, risk aversion. So we, apart from electrical engineers, anybody which is outside the domain of electrical engineering are not going to take the risk. I do not feel any social pressure to purchase electric car. Yes, of course, in our society, then some people in my family and friend circle who are important to me think that I should purchase an electric car. People who are close to me would like me to purchase an electric car. All these things. So not only the technical aspects, but the social and financial aspects also decide whether a person will go for electric car or not. And regarding energy efficiency, it is the driving or way of driving, we can say, because the same vehicle which can give you a 200 or 250 kilometer range may give 100 kilometer range if it is not driven very responsibly. Okay. And for example, in our state there is no road tax, and there is 1.5 lakh subsidy for purchasing electric vehicles. So eventual benefit goes to about 3 lakhs per car. For example, you purchase a 15 lakh car, and actually you end up paying 12 lakhs, because 3 lakhs you get in return as no RT, no GST, subsidy and all those things, but still the penetration is low. Okay. So I have given the references below the various slides. You can go through it. And this is an interesting website which can provide the detailed energy efficiency for all electric vehicles that are available throughout the world across various years. So you can go through this. It's a nice, interesting one. Okay. And other references are provided below the slide. There are numerous papers. It is not possible to discuss each and every one. So with this, I conclude.